supplementary diet must contain at least 16% protein. We use material balance formulas recommended by WUCA 2012 to come up with this. The sample A is the control, 100% maize ogi, that is akamu or cocoa. Then the sample B will be gotten from maize and African yam bean flour. Sample C will be gotten from maize flour and soybean flour. Sample D will be gotten from maize flour and African yam bean protein isolate, while sample E will be gotten from soy protein isolate and maize flour. If you check the last table that I just checked on 10, if you subject it to this standard, this composition of rats experimental diet showing different level of soybean, African yam bean, and their protein isolate as active fortificants. Several reports by Ahmed of 2023, AK 2024, and Gigi 2022 have showed that legumes generally have been reported to be rich in bioactive compounds like catechin, quercetin, flavone, and polyphenols, which all have anti-diabetic effects that have been shown to be efficacious in treating various types of diseases. So we decided to come up with this table. This is a table that we're using in feeding our albino rats to see if they develop or the fortified product I'm trying to come up with will be able to treat the problem of diabetes. Apart from that, we decided to not just design that table. That table, if you subject it to National Research Council 1995 and AOC, Association of Analytical Chemists 2012, you can see that all our table falls within, our formulated diet in the last table falls within these permissible limits. This experimental diet that we fed to streptozin-induced diabetic rats. So the products will be developed, then the rats will be induced with diabetes, and the various food group will be used to feed the albino rats. This figure 1 showing the processing flowchart for processing of maize ogi. This figure 2 showing the processing flowchart for African yam bean. These are flowcharts for processing of soybean flour. Soy seed will be gotten to be salted to remove foreign particles, to be washed with clean water, steeped at room temperature for 8 to 10 hours, to be decanted, boiled for 100 degrees centigrade for 30 minutes, called drained, dried at 65 degrees centigrade for 48 hours, milled using artificial mill, and sieved using 250 UME sieve. This is a flowchart for the processing of African yam bean protein isolate. After we might have gotten our African yam bean flour, we're going to produce an isolate from the African yam bean flour. Same thing here that is repeated for soybean flour. After getting the soybean flour, we are going to follow this flowchart to also get our isolate that we use in the fortification. Then the analysis, in line with our objectives in the second slide, the functional parameters that we'll be looking at, I will be looking for in the lab are bulk density, oil, water, swelling, foaming, and gelatinization temperature. And they'll be determined according to the method of WUCA 2005. They will also look for the pasting properties of maize ogi enriched with flours and protein isolate from African yam bean and soybean. The peak viscosity, throw, breakdown, final setback peak, and pasting temperature will be determined using a machine rapid viscoanalyzer. Now go to the proximate composition analysis, the food protein, the ash, food fats, moisture, fiber, energy. Then carbohydrate will be determined by difference according to AOC 2012. All the proximate parameters will be determined by AOC 2012. Now look at selected micro ingredient composition of maize-based ogi enriched with flours and protein isolate. So I'll be looking at about 7 elements here using an atomic absorption spectrometer according to the method of AOC 2012. So I decided to select this one because these are the most dominant one in the blends I'll be using for my analysis. Now look for, I'll also be checking for A traditional composition of maize-based will be enriched with flax and protein isolate from African yam bean and soybean, phytate, tannins, oxalate, and creatine inhibitors. We check using the methods of Omuka 25, AOC 2005, and Rozomi and Kashiro 2013. We're looking at the AV antioxidant properties of enriched with flax and protein isolate from African yam bean. I'll be checking the radical scavenging properties, ferrufra, sclerosid, SRSA, and hydroxyl radical scavenging activity going to Ajibola 2013. Feeding rather using the various blend. This has been shown in our previous level. Then the anti-diabetic analysis. So I'm going to check to see if the fortified or the product that we develop will be effective in handling some of the issues in diabetic patients like total cholesterol determination using NATO 1988 serum triglyceride determination, McGowan 1983, and serum high density lipoprotein cholesterol Gordon 1997. The ancestral analysis of the sample. The developed product is going to be gauged on the basis of aroma, mouthfeel, appearance, taste, consistency, and overall acceptability to see the rating of the product that's going to be developed. Statistical analysis will be done using Duncan multiple range test, where differences will be considered at 95% level. These are the references. Thank you all for your attention.